In traditional network designs, a single uplink failure can bring an entire access network down. When a core switch fails, all downstream switches and services are affected, creating a critical single point of failure. With VSU, two physical core switches operate as one logical unit, synchronized through a dedicated VSL link. Access switch connect using LACP, providing active uplinks to both core members at the same moment. If one core fails, traffic instantly shifts to the remaining switch with no interruption. This is a true high availability built by design. Hello everyone, this is Ahmed Shukri, Reyee post-sales engineer. In the past months, we received many requests from our partners and professional clients asking about Reyee stacking, how the stack works in Reyee switches, how it appears in Reyee Cloud and local web user interface, how to configure, verify, troubleshoot it properly. So today we will build a VSU deployment from zero, step by step. Our VSU core will be created between two CS83 switches. And we will connect two access switches using LACP, Dynamic Link Aggregation. Today, our video will be divided into three sections. Section 1, VSU Setup, Verification and Troubleshooting. Section 2, LACP downlinks to access switches, Setup and Verification. Section 3, Dual Active Detection using BFD to prevent disaster scenarios. And finally, we will see what VSU looks like on the local web UI and on the Reyee Cloud. Let's start. This is our physical topology for today's deployment. At the beginning, you can see both core switches operating independently. Each one is separate, with its own interfaces and uplinks. Now, slowly, we bring them together. At the configuration progress, these two standalone switches transform into one unified virtual switch, forming our VSU core. Below the VSU, we have our access switches. Each one is connected through LACP, Dynamic Link Aggregation, on its uplinks, providing bandwidth increase, redundancy, and faster conversions. Let's begin with Section 1, configure the VSU from scratch. Right now, I'm using placeholders. I want you to understand the logic first before I reveal the real configuration. In a moment, I will switch to my actual ports, actual domain, and actual priority, and you will see the VSU from live. Now we need to change the name. VSU-master. And now is the turn for the VSU setup. We started with switch, virtual, domain, 1. Now we need to set the priority to make this one is an active one. Switch 1, priority 200. The default is 100. We can check it like here. And we need to give this switch a description. Switch 1, description, switch A. Exit. Now is the turn to the setup of the VSL links. The keyword here is VSL-port. And now port member interface, we need to apply it to the 10 giga uplinks, which is port 26, 27, 28. So it is interface 10G 0/26, 27, 28. End and write to save it. File now switches the console to the standby member. Now we are connected to the VSU standby switch. We need to change the name. Okay, now we need to configure the VSU. And this switch will be our standby one. So switch virtual 1, domain 1, switch 2, priority. We need to make it less than the active one. We can make it 100. We need to give it a description, switch 2, description, switch B. Exit. Now is the turn to the VSL link, VSL-port. Okay, now this switch is only 16 port, not like the active one which is 28. So the 10 giga here is port 14, 15 and 16. So port dash member interface 10G 0 slash 14, 15, 16. Exit. We need to save it. Now, both switches are ready. The next step is converting the standalone mode into virtual mode. Now, the console will be plugged into the VSU master device. I will remove it from this standby one. Now we are on the master. Now it is only one command line that converts the switch from standalone mode to virtual mode. So it is switch convert mode to virtual. Now the switch will reload after we press on yes. So I will choose yes. Now I'll move the console to the VSU standby device. The same switch convert mode virtual. Yes. Now we connect the VSL cables 10 giga between both units, and after 1 minute we verify the status. Now and after both of them has been rebooted, we can make our verification. So now I connected the console cable again to the VSU master unit. At this stage, the switch is asking me to set a new password. That's completely normal, because once we convert the switch to virtual mode, it rebuilds a fresh configuration file. In VSU mode, the system treats both devices as one logical unit. So a new login and enable password must be created for the unified system. I'll set a secure password here and then we will continue the verification. Now we have some command lines to make our verification, and the most popular one is show switch virtual. Show switch virtual. Here we are able to see the switch ID, domain ID, priority for each of them, position local or remote one, status is OK, and the role active or standby. And this is our description, switch A and switch B. And if we need to know all the configuration, we can run show switch virtual config. Show switch virtual config. We are able to see the switch MAC address, switch virtual domain 1, priority, description, and the VSL interfaces. And the same for switch 2, all information here. If we need to check the VSL link health, we can run show switch virtual link. Receiving and transmitting data is okay. We just run uptime 10 minutes. If you want to know all the command line can make the verification, you can run show switch virtual and question mark. Before I'm going to show you the switch virtual balance, I want to tell you that if you wanted to access the other device, which is the VSU standby, you can access it from here. Just session, device, and the switch ID 2. Now you are on the standby. Session device 1. Now we are on the master again. Last command line we will use here, show switch virtual balance. And the result, we have something called aggregate port LFF enabled, ECMP LFF enabled. And this is enabled by default. This point is an important one. LFF is short for local forward first. Prevents unnecessary traffic cross VSL line. Aggregate port LFF considered layer 2. ECMP LFF is short for equal cost multipath, considered layer 3. And here, as you can see, it is enabled by default, and disabling it is not recommended for normal deployments. So, in simple words, local forward first protects your VSU by keeping traffic local when possible, and only using the VSL link when absolutely required. This is why we kept it enabled by default. Section 2, configuring the LACP uplinks from the core switch to the access switches. Before I show you my real configuration, let's understand the logic first. Each access switch uplink uses a port group, and both ports must share the same group ID. Once the group forms, the aggregate port becomes the logical trunk interface. Now let me apply the real values on my setup. I want to show you a very important point. If we run show interface status, The port ID, as you can see here, is not the normal one. We deal with it before. So, before we start the LACP configuration, I want to highlight an important point. Once the switches enter VSU mode, the physical port numbering is no longer the normal standalone format. We now have three dimensions for every port ID: switch ID, slot ID, port number. So, for example, G1/0/1, it's a Giga interface on switch 1, slot 0, port 1. G2/0/1, same physical port position, but on switch 2. This is why both interfaces must be configured in the same port group, because they present the same uplink on both members. Now let's start the LACP configuration. We will start to configure the LACP group with the first access switch. Interface G1/0/1, port group 8, mode active. Interface G2/0/1, port group 8, mode active, exit. Interface aggregate port 8, switch port, mode run, aggregate port, load balance, source, destination, IP. Interface aggregate port 8, no shutdown, end. And now we configure the second LACP group, which will be between the VSU and the access switch 2. Interface Giga 1/0/2, port group 7, mode active. Interface Giga 2/0/2, port group 7, mode active. Interface aggregate port 7, switch port, mode run, no shutdown, aggregate, load balance, source, destination, IP, and write to save it. Now I'll connect the console cable to the access switch 1. Enable, set the password. We need to change the name, configuration, host name, access switch 1. Now we will configure two ports interface range G0/1-2. Port group 8, mode active. Interface aggregate port 8. Switch port, mode run, no shutdown. Aggregate port load balance. Source, destination, IP, and save it. Now I'll connect the console to the access switch 2. Enable, we change the name, host name, access switch 2. Interface range, port group 7, mode active, interface aggregate 7, switch port, mode run, no shutdown, aggregate port, load balance, source, destination, IP, and save it. And now, after we connected the LACP cables, let's verify and troubleshoot the LACP configuration. Now we are back to connect to the VSU master. We will start with show interface status. Here we can scroll down until we reach aggregate port 8 and 7. Both interfaces are up with a total bandwidth of 2000 megabit per second, confirming that the two physical interfaces are successfully bonded into a single logical link. This is our first indication that the LACP is functioning as expected. Second command line, show LACP information port. Show LACP information port. This command helps us confirm the member ports assigned to each aggregate port. And finally, we can run show aggregate port summary. Here we clearly see that aggregate port 7 and aggregate port 8 are in trunk enabled states. Each bundle contains one port from switch 1 and one port from switch 2, which confirms proper LACP distribution across the VSU system, ensuring redundancy and load balancing. With the final and third sections on this video, the most important part, preventing a network disaster. This is where DAD plus BFD becomes your lifesaver. Now it's time to protect our network from a potential disaster. And here our hero is DAD, bad, dual active detection. After the VSU becomes stable, we introduce a dedicated BFD dual active detection link. BFD stands for bidirectional forwarding detection. This link is not part of the VSL, it is not part of the LACP. It is a completely independent protection link. Its only mission is simple: prevent a dual active situation if the VSL ever goes down. Because if the VSL fails and both switches believe they are the active unit, the VSU splits, both become active, and the entire network collapses. The BFD link acts as a heartbeat channel, constantly checking if both switches are alive. If something goes wrong, the standby switch immediately steps back and prevents this disaster. Because BFD is layer 3 protocol, not layer 2, so making the port layer 3 is a mandatory in Reyee VSU. So we will start. We will apply the BFD into two ports. First one is convert to layer 3, no switch port. Second port will be enter the VSU switch virtual domain 1, dual active detection BFD, dual active BFD interface 1/0/11, and write to save. After we connected the DAD cable, time for our final BFD troubleshooting. We can use show running config include dual active. Dual active. Here we are able to see the two layer 3 ports in the BFD setup. Also we can run show switch virtual, show switch virtual dual active, and here we can confirm that both ports are up and also the BFD dual active detection is enabled. Now and before we finish, I want to show you how the VSU looks from Reyee Cloud. But before, I need to get a source of the internet from this gateway. Connect it to our core switch. Because one of the most common questions, will the VSU appears as a one device or two? And how does management work? With VSU, our two switches will operate under one virtual system, meaning one IP and one management point. Let's open Reyee Cloud and see it live. Here we are inside the Reyee Cloud dashboard. As you can see inside the topology, both physical switches are now detected as a one logical device, managed under one single IP, which confirmed that our VSU is formed correctly. If we check the uplink connections, we can clearly see the links to the access switches, labeled as aggregate port 8 and aggregate port 7, exactly as we configured earlier. Now, if we click on the VSU master, we can monitor everything in one place: interface status and traffic flow, VLAN configuration, layer 3 routed ports including the ones we used for BFD, port statistics and utilizations, and finally, the log history for troubleshooting. If we move to configuration section, notice this point. We can see both line cards on the same management panel, the same way you manage a modular chassis switch. From here, we can push configurations, apply VLANs, and much more, all from one interface. So, from the cloud perspective, this is not two switches anymore. This is one unified VSU system, one IP, one brain, one management. Now we have seen the cloud view. Let's move to the local web user interface. This is for engineers who prefer on-premise or environments without internet access. The idea is the same. One virtual switch, one IP, one management system. Here we can see the VSU recognized as a single device, all managed under one management IP. If we scroll down, we can see both members listed, the master and the standby, but the configuration is unified across both devices. Moving to network, then port configuration. At the top, we can see the layer 3 interface used for the BFD dual active detection link. As we scroll down, we can see all layer 2 interfaces. showing the physical port locations on each member switch, but controlled logically from one interface. This is where VSU reduces management complexity. One place, one configuration. We can also see the aggregated ports for our LACP links and the detailed assignment of each member. Now scrolling to VSU configuration. Here we can clearly see the master and the standby rules, their VSL port assignments, the priority values, and the status indicator for each unit. If we pressed on the VSL link, you are able to see the full information. At the bottom, the visual interface confirms everything. BFD ports are marked with a green check. VSL ports are shown with a diamond icon. Aggregated ports appear with the port group number inside them, like 7 or 8. So from the local interface perspective, just like on the cloud, this is no longer two switches. This is one unified VSU system. One IP, one configuration, one brain, and that's the power of the VSU. Thank you for watching. I hope this video helped you understand clearly the VSU, LACP dynamic link aggregation, and DED PFD protection. And see you in the next video.